Unit 7 group quiz. First thing on all problems you want to check for is your GCF. The GCF is 4. We take out 4. I have x squared minus 4 over 2 minus x. And then check to see if you can factor further. This is a difference of squares because 4 is also 2 squared. So we have 4, and then I have x minus 2 and x plus 2, and this is over 2 minus x. If you look, x minus 2 and 2 minus x are similar, but they are not the same. If you take out a negative 1, which will change that to a negative and that to a positive, now these two are the same. Because if you notice, the 2 is negative here, 2 is negative here. X is positive here, x is positive here. So these can be canceled. This negative 1 can go with the top or the bottom. So when we write this, I'm just going to write the negative with the top. So we have negative 4 times x plus 2, and that's my answer. Okay? Questions on 1? Question number 2. Again, we always check for what first? GCF. So I can take out an x, and I'm left with 2x. Oh, not just an x. What else can I take out? I can take out a 2x, right? So we're going to take out a 2x, and I'm left with x squared plus x minus 2. Okay, in the denominator, I'm going to go ahead and take out my GCF here too. What's my GCF in the denominator? X. And then I'm left with x squared minus 5x minus 14. Okay, so on the top, I'm going to check for diamond. If I were to diamond and factor, is there anything that multiplies to be negative 2 and adds to be 1? Good, 2 and 1. So we're going to have x plus 2 and x minus 1. That multiplies to be negative 2, adds to be 1. And the denominator, I have x. What multiplies to be negative 14 and adds to be 5? X minus 7 and an x plus 2. So that makes a negative 5 and a negative 14 when you multiply. Is there anything you notice we can cancel? Okay, x plus 2 is good. Anything else? Good, the x's that are outside. Anything else that has a plus or minus with it, it has to be exactly the same in order to cancel them out. So that means my answer is 2 parentheses x minus 1 over x minus 7. Okay, number 3. What do I always check for first? GCF. What is my GCF on number 3 on the top? A 3xy. Okay, so we're dividing each of these by 3xy and seeing what is left over. Okay, so when I do that, the first one we have x squared plus 4xy plus 4y squared is what I'm left with on the top when I reduce it all. Okay, the denominator, can I take out anything? Is there a GCF? So between 6 and 12, I have 6 x squared and a y. And so I'm dividing each of these by 6x squared y to see what is left over. And I'm left with x, because the 6's cancel, the y's cancel, 2 of the x's cancel, plus 12 divided by 6 is 2, the x squareds cancel, and the y squareds cancel. Oh, no, sorry. 1 of the y, and then we're left with the y. Okay. So now we check, can I factor anything else? Can I factor further? Can this be factored up here? Okay, so I have 3xy. I'm going to make my 2 parentheses. Whenever you have an x squared in the front, you write the x in the front. If you have a y squared at the end, you write a y at each of the ends. And then all you're still looking at is what adds to be 4 and what multiplies to be 4. So what 2 numbers work? Good, so we just have our plus 2 and plus 2 there. Over, and then I still have 6x squared y and x plus 2y. So do we notice anything that cancels? 1x plus 2y. And then 3 cancels and 3 goes into 6 2 times. This x cancels with one of those x's, and the y's cancel. So on the top I have x plus 2y, and the denominator I have 2x. Can I cancel out this 2 and this 2? No, because remember, anything that's adding or subtracting, that whole thing is stuck together like glue, and you can't cancel anything with it unless it's exactly the same. Okay, example 4. Always check for GCF. There is no GCF. So then when you have 4 terms, you need to group them. What is my GCF of the first group? Good, x squared, and I'm left with x minus 5. What's my GCF of the second group? Good, you're going to take out a negative 3, and we'll be left with x minus 5 when you divide each of these by negative 3. Okay, so now my GCF is actually x minus 5. Okay, so we are taking out x minus 5, and we're left with whatever is left in front, which is x squared minus 3. In the denominator, what adds to be negative 8 and multiplies to be 15? Good, x minus 3, x minus 5. So those multiply to be positive 15 and add to be negative 8. So we can cancel out the x minus 5s. And can I cancel out any of this stuff? No, because it's not exactly the same. So my answer is x squared minus 3 over x minus 3. Are we good? All right, example 5. This is almost like 4 problems in one, okay? So we have to factor out each of these things. So on the top here, always check for GCF. Is there GCF? Yes, we have a 3, and we're left with x minus 2. Can the denominator there factor? Difference of squares, because 4 is 2 squared, so we have x minus 2, x plus 2. Times. Am I going to flip this one?
No.
No, when do I flip? When it's dividing. It's not dividing, okay? So the top, there's no GCF. We have to use our over, under, bottoms up. So over by 3, we get x squared plus 4x minus 12. The two numbers that work are x plus 6 and x minus 2. Those add to be add to be 4, multiply to be negative 12. Anytime we go over by 3, we also have to go under by 3. So this reduces to 2. So we get x plus 2, and then here we bring our bottoms up, and we get 3x minus 2. Okay, is there a GCF here? On the bottom, yes, what's my GCF? X, and then I'm left with 9x squared minus 4. Can this be factored further? Yeah, because 9 is actually 3 squared, x squared, and 4 is 2 squared. So I have my GCF of x in front, and then those are a difference of 2 squares. So we get 3x minus 2 and 3x plus 2 when you separate those. Okay, and so now we're going to cancel any like terms. So, am I going too fast?
Oh, no.
Okay, so we have x minus 2's, I have x plus 2's, I have a 3x minus 2. Do we see anything else? Nope. So that's my answer. There's only a 3 left on the top, and x times 3x plus 2 left in the denominator. Okay. Can I change it? All right. Number 6. Again, you have a whole bunch of problems in one here. Okay? Anytime you see a cube and you can't take out a GCF, you want to check to see if both of them are cubes. So 8 is really the same thing as 2 cubed. So that means I can factor cubes, okay? So your first parenthesis is you just take off the cubes. So I have 2 plus x. Keep them in the same order as they're written there, okay? Then my first term in this parenthesis is the first term squared. So 2 squared is 4. Then it's the opposite sign, so it'll be minus. And you multiply 2 times x together, which is 2x. And then your last term in here is the last term squared, so that's plus x squared. In the denominator now, 4 is the same thing as 2 squared, so this is a difference of squares. And we get 2 plus x and 2 minus x times. Okay, there's no GCF on the top, but I have 4 terms, which means I'm going to group. So I'm grouping the first 2 and the last 2. What's my GCF of the first group? X squared, and I'm left with x plus 2. My GCF of the second group is 7, and I'm left with x plus 2. So that means that my GCF of the entire problem is actually x plus 2, and I'm left with x squared plus 7. Okay, this denominator, is there a GCF? It's x, so we take out an x, and I'm left with x squared minus 2x plus 4. Is there anything that multiplies to be 4 and adds to be negative 2? No, because 4 and 1 won't make 2, and 2 and 2 won't make 2. So that can't be factored any further. So I just have x, and then x squared minus 2x plus 4. Okay, so now we've factored everything. This is my problem. This is where I'm looking. So 2 plus x and 2 plus x, those can cancel. If you notice here in these parentheses, look at to see if they're the same, because they look very similar. So check. See how this 4 is positive? This 4 is positive. This is a negative 2x, negative 2x. Positive x squared, positive x squared. So everything's the same, they're just written in a different order. So can I cancel those? Yeah. So as long as they are the same numbers and same signs, you can cancel them. Is there anything else that's like that I can cancel? No. So that's my answer. On the top I have x plus 2 and x squared plus 7. And the denominator I have left this x and then 2 minus x. So that's your answer. We're good? All right, 7. This one is division, which means what? We're going to end up flipping the second and changing to multiplication. So we'll start factoring here. So x squared minus 4, what am I going to do with that? Good, difference of 2 squares. So it'll be x minus 2, x plus 2. Okay, the denominator. What am I going to have to do there? Good. So we're going to go over by 2. I'm going to write it down here for a second. We have x squared minus 5x plus 4. What numbers multiply to be 4 and add to be negative 5? Very good. X minus 4, x minus 1. But since I went over, I need to go under by 2 and reduce. This reduces to x minus 2. This doesn't reduce, so we bring our bottoms up, and we get 2x minus 1. Are we all okay with that? Okay. Then we're changing to multiplication, which means that this is going to go to the top. So 4 is really 2 squared, and 1 is really 1 squared. So that's difference of squares. So on the top, it's going to be 2x minus 1 and 2x plus 1. Okay, the denominator now, I'm going to do my over-under again. So I'm going over by 2. So I have x squared minus 3x minus 4. What numbers multiply to be negative 4 and add to be negative 3?
Negative 4 and 1.
Very good. X minus 4 and x plus 1. And since I went over by 2, I need to go under by 2 and reduce. This reduces to 2, so I have x minus 2. This, we bring our bottoms up, and we get 2x plus 1. Okay, so here is my problem that I'm dealing with now. We are going to reduce any like terms. And so we have x minus 2's. We have 2x plus 1's. We have 2x minus 1's. And do we have anything else? Are these the same?
No.
Is there any way of making them the same?
Multiply by negative.
If I multiply by negative, that will make the x negative and the 2 positive. Does that make it the same? Nope, won't work. So that's my answer. X plus 2 over x minus 2. Okay, we good? All right, number 8. There's no equal sign, so I can't get rid of my fractions. So factor this. We factor that. What multiplies to be 6 adds to be 5? X plus 3, x plus 2. So what will be my common denominator? X plus 3, x plus 2. Good. Doesn't matter which order I write them? No. Okay, so then we go and we look at this first fraction. It has an x plus 2, but it still needs the x plus 3. So that's why I multiply the top and the bottom of this one by x plus 3. We already have a 5 there, so we distribute. 5 times x is 5x, and 5 times 3 is 15. When I look at this one, what do I still need?
No, nothing.
Nothing. So we just rewrite what was already on top, because there's nothing more that I need. So we have 6x plus 7. We add those together. 6x plus 5x is 11x plus 22 over x plus 3, x plus 2. Can I factor the top at all? Yeah, I can take out an 11, and I'm left with x plus 2. And then it's over x plus 3, x plus 2. Now, can I cancel anything? X plus 2's. Good. So that's my answer now. 11 over x plus 3. Okay, number 9. If you notice on number 9, these are opposites. This x is positive, x is negative. Here y is negative, here y is positive. So what could I do to make them so they're the same denominators? You take out a negative 1, right. And so then that ends up making the y negative and the x positive. I'm going to kind of rewrite this. So in the front here I have 2 over x minus y. See how I took a negative out here? 2 negatives like this, a negative and a negative, end up making a positive. And I can rewrite this to be x minus y in the denominator, if you want to flip it around. And then I have y on top. So now I can add them, right? Now that they have common denominators. So we get 2 plus y over x minus y. Can I cancel anything? Nope, so that's my answer. Okay, next page. What will I multiply by in order to get rid of all my fractions? What would be the common denominator of the entire problem?
14x.
Good. So I'm multiplying 14x to every single term. Okay, on the first term, the x's cancel. 7 goes into 14 2 times, and we're left with 2 times 2, which is 4. Next term, 14's cancel. I still have that minus there in the middle, and then 3 times x is 3x. Now we move to the denominator. 14x cancels out. I'm just left with a 3. Here, 7 goes into 14 2 times. We have our minus sign, and then 1 times 2 times x is just 2x. Can I factor or cancel anything? No. There's my answer. 4 minus 3x over 3 minus 2x. All right. Number 11. What will I multiply everything by in order to get rid of my fractions here? Good. Whatever your largest denominator is, it's going to at least have to be that big. In this case, 3x squared will end up getting rid of all of the fractions. So we multiply every single term by 3x squared. On my first term here, 1x cancels with 1x left up here. And then we multiply 3x times 8y, which is 24xy. Divided by here, the 3x squareds all cancel out, and we're just left with y. Minus, here the 3's cancel. 1x cancels with 1x up here, and I'm left with 2 times x, which is, can I factor or reduce anything there?
X, take it out.
Because remember, anything with a minus or a plus is stuck together like glue, so you can't cancel it unless everything's the same. So that's it. That's my answer. 24xy over y minus 2x. Okay, 12. Two fractions. In order to add or subtract fractions, you need to have what?
Like
Good. Like denominators, common denominators. So we're going to factor this. What adds to be 5 and multiplies to be negative 14? X plus 7, x minus 2. So that means that's actually going to be my common denominator. X plus 7, x minus 2. So I'm writing this out twice. On the first fraction, what's missing? What's missing from the denominator?
The x squared is 2
Nothing, right?
Oh,
The first fraction, nothing's missing, right? So we just rewrite the top. I was tricking you. X squared minus 5. Okay, on this one, what's missing? X minus 2. So that means we're going to multiply the top and the bottom by x minus 2. And that means I'm going to have to use my box method, okay, or FOIL. When you multiply that out, you're going to get x squared plus 1x minus 6. Okay, but because of that minus sign, what do I need to do with it? Distribute it. So we get a minus, and a plus, and once we do that, we can change this to a plus. So now that I have common denominators, I can combine my like terms on top. So if I have x squared and a negative x squared, those cancel out. I have a negative 1x or negative x, and then negative 5 and positive 6 makes positive 1. And does that end up canceling with anything on the bottom? No. So that's my answer. Negative x plus 1 over x plus 7 and x minus 2. Oops. There we go. Questions? Okay, example 13, it says state the domain. The domain is your x values. So they're asking what x values will make this a true statement. Okay, so your answer is going to end up being all reals except x cannot equal. And what can x not equal? How do we figure out what x shouldn't equal? How do you figure that out? You set your denominator equal to 0, because if your denominator becomes 0, what happens? If you have a 0 in the denominator, your answer is undefined, which is no solution if you get 0 in the denominator. Negatives are okay, you just don't want a 0 in the denominator. So you set your denominator equal to 0 and solve, and that is what x cannot equal. So we end up getting 7x equals 1, we divide by 7, so that's the value. All reals except x cannot equal 1/7, because that's the only thing that will make the denominator 0. Okay, questions on that? All right, this one, you want to check to see if this makes a true statement. So I'm going to rewrite this. We have x plus 7 over and x squared minus 49. Can that factor? Good. X minus 7, x plus 7. And we're seeing, does this equal x minus 7? So if these cancel out, we end up with 1 over x minus 7 equals x minus 7. Is that a true statement?
no.
No, that does not equal. So therefore, my answer is C. Never. That will never work. Okay. 15, there's an equal sign, so that means I can get rid of my fractions. Okay, when I'm getting rid of my fractions, I have to multiply by whatever would be the LCD, or the common denominator. So what am I going to multiply every term by? Very good. X and x minus 4. Because remember that whole sticking together like glue, so x minus 4 and x are not the same, so we need both of them. Before I go any further though, let's write what our extraneous solutions would be. What values for x will not work? X cannot equal what? 4 and 0. So always check that with your answers. Okay? All right, so on this first term, the x's cancel, and I'm left with 10 times x minus 4. The next one I have plus 3x times x minus 4. And lastly, the x minus 4's cancel, and I'm left with x times x plus 9. Now I'm going to distribute. We get 10x minus 40 plus 3x squared minus 12x equals x squared plus 9x when I distribute through each of the parentheses. Then I would combine like terms and put it in descending order. So we have 3x squared, 10x and negative 12x makes negative 2x, and then I have minus 40 equals x squared plus 9x. Which way should I move everything? To the left, because you always want your x squared term to be positive. So I'm going to subtract x squared, subtract 9x. These cancel. We end up getting 2x squared minus 11x minus 40 equals 0. You can always use your quadratic formula, but your over, under, bottoms up works here. So we're going over by 2. We get x squared minus 11x minus 80 equals 0. The two numbers that work are x minus 16 and x plus 5. Those add to be negative 11, multiply to be negative 80. But since I went over by 2, I need to go under by 2. And so I end up getting x minus 8 and 2x plus 5. And when you set those equal to 0, you end up getting a positive 8 and negative 5 over 2. Do those match my extraneous solutions? No, so I'm good. Okay, 16. What can x not equal? What are my extraneous solutions on 16? Before we figure that out, I should probably factor this, right? This factors to be x plus 2 and x minus 1. So, what are my extraneous solutions? What can't x equal? Good. Negative 2 and positive 1. Since there's an equal sign, we can get rid of all the fractions. What will I multiply every fraction by? X minus 1, x plus 2, whatever your common denominator would be. X minus 1, x plus 2. Okay. On this first one, the x minus 1's cancel. And when you have x plus 2 times 1, which is x plus 2. The second fraction, x plus 2's cancel, and you have 1 times x minus 1, which is x minus 1. Equals. Here, the whole thing cancels, and we're just left with 3. That was just supposed to be a 1. Okay, so we combine our like terms. X plus x is 2x, and 2 and negative 1 makes plus 1 equals 3. So to solve for x, next I would subtract 1. We get 2x equals 2, and lastly we divide by 2, so x equals 1. Well, when you check with your extraneous solutions, it's saying x cannot equal 1, can it? So this won't work. Since there's no answers left, the answer is just no solution. Okay? I'm going kind of fast, sorry. All right, example 17. What would be my extraneous solutions? What can x equal on this one? Good, 0 and negative 3. Yeah, and then what's my LCD, or what am I going to multiply everything by? X times x plus 3 to get rid of all my fractions. X times x plus 3 to everything. Okay, on my first one, the x's cancel out, and I'm left with 5 times x plus 3. My second fraction, nothing cancels, or second term, and I just have negative 2x times x plus 3. Equals, here my x plus 3's cancel, and I'm just left with 2x. Next I distribute through, and I get 5x plus 15 minus 2x squared minus 6x equals 2x. I would write this in descending order and combine my like terms. So I get negative 2x squared, and then I have a 5x and a negative 6x, which makes negative x, plus 15 equals 2x. Which way should I move everything? I'm going to actually move it to the right. Why will I move it to the right? Good. You want your highest exponent to be positive. So I'm going to add 2x squared. I'm going to add x. And I'm going to subtract 15. So when I do that, I'm going to write it in descending order. So I have 2x squared plus 2x and x makes 3x, and then I have minus 15 equals 0. You can try your over, under, bottoms up, but it won't work. So you have to use your quadratic formula. Just in case you don't remember, that is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? On this problem, a is 2, b is 3, c is negative 15. Once it's written in descending order and your squared term is positive. So when I plug in my numbers, this into my quadratic formula, I get negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 15 all over 2 times 2. Okay, 3 squared is 9. Negative 4 times 2 is negative 8. Negative 8 times negative 15 is positive 120. 2 times 2 is 4. Okay, and 9 plus 120 is 129. Okay, can 129 break down to bring out any pairs? No. So that's your answer. Negative 3 plus or minus the square root of 129 all over 4. Okay, next problem. Two fractions you're adding. You need to first get common denominators. This factors to be x minus 6, x minus 4. This factors to be x minus 6, x plus 1. So what would be my common denominator on this problem? You need x minus 6, x minus 4, and then a x plus 1. So it has 3 denominators. So I'm writing my two fractions. So on my first fraction here, what is it missing? X plus 1, good. So we're going to go 5 times x plus 1, which is 5x plus 5. Don't forget to distribute that 5 to both those terms. What am I missing on the second fraction? X minus 4, and we're going to distribute it, and we get 3x minus 12. Then you combine your like terms. 5x and 3x is 8x. 5 and negative 12 makes negative 7 over x minus 6, x minus 4, x plus 1. Can I factor or do anything to make that reduce? No, that's my answer. All right, last one. Okay, can I get rid of my fractions on this one? Yes, because there's an equal sign. You can get rid of fractions anytime there's an equal sign. What am I going to multiply by to get rid of the fractions? Good, because at least has to be as big as your largest exponent. So we go x squared to every single term. Okay, when I do that, 1 times x squared is x squared. The second one, this x cancels with one of those x's, and we have 8 times x, which is 8x. Here the x squareds cancel, and we're just left with negative 1 equals, and 0 times x squared is 0. Okay, is there anything that multiplies to be negative 1 and adds to be 8? No. So, a equals 1, b equals 8, c equals negative 1. Using our quadratic formula, we get negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 1 all over 2 times 1. 8 squared is 64. Negative 1 times 1, or sorry, negative 4 times 1 times negative 1 makes a positive 4, and that equals 68, and this makes 2. So we have negative 8 plus or minus the square root of 68 all over 2. 68 is an even number, so I know that it's 2 times something. So that breaks down to 2 and 34. 34 is even, so I know that that is also 2 and 17. So there's the pair of 2's. So I have negative 8 plus or minus 2 root 17 all over 2. Now this can reduce. I suggest you write this into two fractions when you reduce it. Negative 8 over 2 plus or minus 2 root 17 over 2. So when you reduce negative 8 divided by 2, that makes a negative 4. Plus or minus, here these 2's cancel, and you just have root 17. And that's your answer.